Okay, this is Mr. Hudson, and we are going to review cumulative test, or in our case, pretest 1A. So this is what you should be working on this week. I'm going to go over these problems, and we'll just go ahead and get going. All right, the first problem has to do with this pie, and it says a high school ski club has 42 members. Circle graph below shows what percentage of the members fall into given grade brackets. And we're going to use a protractor and measure the angle of the wedge that represents grade 9 bracket. And then ultimately you want to know how many members of the ski club are in grade 9. All right, we know that the circle measures 360 degrees. So each of these pies will be some amount of degrees out of 360. So you take your protractor, line things up, you got your hole, put it on the center. Now I've already extended this line. You can take your protractor and extend these lines on your work. You almost have to do that. You can even do it here too. Just extend your lines out. That way you can easily get your protractor on there. And once you get it figured out, it measures, you're going to measure the inside slide here, and it's 60 degrees. So that angle is 60 degrees. Now, we want to know how many members are in 9th grade out of 42 members. So that's where you set this up this way. You would say 42 times 60 over 360. Now if you reduce this down, that's 1/6. So you can calculate it. You can say 42 times 60 divided by 360, or you can say 42 times 1 and divide by 6 if you reduce that. All right, so your answer then is going to be ultimately 7. So you've got 7 members that fall in this bracket, 9th grade bracket, out of 42. So that's your answer. All right, number 2, it says give 2 different names for the lines shown in the diagram. So we have a little a here, lowercase a, so that's one way to name it. It's line A. And then the other option is to pick 2 points. So we have 2 points here, A and B. And put your line above it there. Those are the only 2 ways to name a line. You know, this way and that way. All right. Let's move on then to 3. Points A and B lie on plane M. Does line AB lie in plane M? And justify your answer. If you make a little plane, all right, this is plane M, and you put AB on it. So do they? It says they lie in plane M. Does line AB line in plane M? So remember, any 2 points will make a line. All right, and it says justify your answer. Now if you look in postulate 8, that stands for postulate. It says if 2 points lie on a plane, then the line containing the points lies on the plane as well. So you can check out postulate 8 for that wording. If 2 points lie on a plane, then the line containing the points lies on the plane. Number 4, let's move on to number 4. It says find the distance A to C on the number line. Now, it's easy to count, obviously, 1, 2, 3, 4, 5 units between A and C. The other way to do it, the official way actually, is to use these signs. And these are absolute value signs here. All right? And you would take the value of A, which is 4, and subtract the value of C, which is -1. So it's always be subtracting. So 4 minus and then -1, so -1. 4 minus -1, of course, is going to be 5 in the absolute value signs. And of course, anything that comes out of there is going to be positive. So the absolute value of anything is, of course, positive, and the answer is positive. Remember, the absolute value is just relating to the magnitude or the size of something. So whether it's from 0 to -4, the absolute value of -4 will always be 4 because you still have 4 units from the 0. 1, 2, 3, 4. Likewise for +4. You still have the magnitude of 4 units from the 0. So that's why they use absolute value. All right, let's go to number 5. In the figure below, QR is parallel to ST. UV, which is this line, is perpendicular to QR. And WX is perpendicular to QR. What is the relationship between UV and WX? All right, so UV and WX. All right. We have the rule that if two lines are perpendicular to the same line, then they are parallel to each other. So if two lines are perpendicular to the same line, they're parallel to each other. If you go to lesson 5, you'll read I believe it's either a postulate or a theorem that relates that exactly. All right. But so what's the relationship with these two? UV and WX? Well, they're parallel. UV is parallel to WX. The reason we know it is because of that postulate or theorem that's in Unit 5. I don't remember which, sitting here talking about it. But you go back and check it. If two lines are perpendicular to the same line, then they are parallel to each other. And again, UV and WX are perpendicular to line QR. So they have to be parallel. Number 6. Turn that just like that. Point Y lies on segment XZ between X and Z. Alright, so let's make that. So you have X, you have Z. So we have the segment XZ, and they say that point Y lies on XZ between these 2 points. So we'll just put point Y in here. Then they give you the fact that XY, this distance, is 9 units. So I'm going to write that in. And then they say XZ, that's this whole distance, is 19. So I'm going to put little brackets up here to show that this whole distance is 19. And you can put arrows if you choose. So we need to find this distance. And this becomes nothing more than segment subtraction. So segment subtraction is what we do. So you can subtract the little segment from the big one to get that one. Obviously, you can set up many ways, but you can name that X if you want. Algebraically, it's an unknown. So X equals 10. So that YZ equals 10. And you could say the other option is to call it YZ. It's probably the better option. All right, so that's how you get that answer. Number 7, turn that just right there. What are two different names for the planes shown in the diagram below? All right. Well, one option is the slightly italicized capital letter in the corner, so we could call it plane Z. And then the other option is find 3 non-collinear points on the plane, that would be these 3, and use those to name the plane. You would not use that, and you would not use that. This one is not on the plane. It's non-coplanar. This is not naming a point, but the plane itself. So you could name this B, plane BCD, or use any arrangement of these letters to name the plane. And remember, they are non-collinear. Number 8, classify XYZ, that's angle XYZ, and use protractor to find its measure. All right, classification means that you're going to look at it. Is it acute? Is it obtuse? Or is it straight? And of course, it's less than 90 degrees. 90 degrees would be somewhere in here. It's less than that. So it is acute. That's the classification. You get your protractor again and extend your line like I did there. You can do both or one or what have you. Carefully measure it. Comes out to 30 degrees. So that's the measurement. Number 9. Name 4 points, 2 lines, and 2 planes in the diagram below. All right, so number 1, we're going to name 4 points. Y, Z, X, W. Or W, X, Y, Z. That's 4 points. Do not use these. This is the name of a plane. That's the name of a plane. All right, so 2 lines. WX is a line. WX. And YZ is a line. Be sure to put your arrows up here when you name the lines. You can use 2 capital letters. Finally, 2 planes. All right, so we have planes M and plane N. M and N. And that names the 2 planes. Number 10. Karen sledding down a hill from the top to the bottom. The distance from the top of the hill to the bottom is 185 yards. How far will she have to slide before she reaches the midpoint of the hill? Midpoint, that's halfway. So 185 divided by 2. And I think I already did that calculation. It's going to be 92.5 yards. So obviously the whole thing here, the whole point here is understanding midpoint. All right, let's go to the next page. When taking pictures, photographers often place their cameras on a 3-leg tripod so the camera will not wobble. Explain why a 3-leg tripod would not wobble, and use postulates to explain why this is true. All right, again, we talked about this in class where you have any 3 non-collinear points. If you spread them out evenly like that, then that's going to give stability, and it's going to find a plane. If you look at, go back and study your postulates, and of course in your reviewing you can look at lesson 4. It talks about 2 of them. One is postulate 6, which talks about 3 non-collinear collinear points making a plane, any three non-collinear points making a plane, that would refer to this. Or you could look at postulate 9, which is the expansion postulate, and it talks about any 2 points will make a line, any 3 non-collinear points make a plane, and any 4 non-coplanar points define space. So that also refers to that. So, we're looking at postulates 6 and postulate 9. And of course, they're out of this lesson. You can, if you explain it, the postulate, any 3 non-collinear points define a plane, and you've done a good job with that, answering that. All right, number 12. Identify the coplanar, non-coplanar lines in the diagram. So we're going to look at this. This is a plane, and we have 2 lines that are crossing or intersecting each other. Okay? Well, we have 2 lines intersecting each other on the same plane. So lines A and B are coplanar. And they will always be coplanar because they cross or intersect at a point, and then you can go to the 2 lines, let's say, and here, just pick any 2 places on the 2 lines, and you will always have 3 non-collinear points that define a plane. So they will always be on the same plane. They'll always be coplanar when you have lines that intersect. So there are no non-coplanar points. Non-coplanar points don't exist. That's an empty set. That's the null set. That says that they're not there. 13. The measure of DEF is 46. I just write that in there. The measure of FEG is 40. So find the measure of DEG, that's the big angle. Well, you add these 2 together, that's little angles adding to make a big angle. And so the measure of DEG equals 86 degrees. Classify it. Now, the classification is it acute? Is it obtuse? Is it straight? And 86-degree angle is acute. 14. In the figure below, planes ABC, that would be this plane, and EFG, that's EFG, 3 non-collinear points naming this plane, are parallel. Identify 2 pairs of parallel lines. Well, we know that AB and EF are parallel. AB and EF are parallel, so I can name those 2. And CD and GH are parallel. Okay, so notice that this is a plane transversing these 2 parallel planes. And remember the rule that talks about probably lesson 5, that when you have the same plane transversing or intersecting 2 parallel planes, then it's going to create two pairs of parallel lines. So these are parallel. Likewise here, parallel lines. All right, so 2 pairs of parallel lines, and you can name these 2 if you want to. Well, we didn't, so we're good to go there. 15. Draw as many lines as possible that are parallel to line XY. Let's make line XY. through a point, Z. All right, so here's Z. It's out here. So we got to figure out how many lines that we can draw through this point that are parallel to XY. All right, so we're going to draw a line through it. The answer is there's only one line that's possible to draw through this point that's parallel to this line here. Just one line. All right, through this rule in lesson 5, it talks about I think it was postulate 10 talks about that in lesson 5. I just want to check, make sure, but I really want you to know the rule that through any point not on a line that's on the same plane as this line, and they would be on the same plane because they're 3 non-collinear points. Anyway, there exists exactly one line that goes through that point that's parallel to that line. All right, let's go to 16. All right, so Caesar is painting a design on the wall, and he has 3 painted lines labeled A, B, and C. So let's kind of go over here and draw our 3 lines. Got 3 painted lines. All right, A, B, C. Caesar knows that line C is parallel to the floor, so let's call this the floor here. He knows that's parallel to the floor. He wants A and B to be parallel to the floor. All right, so what he does, he measures the distance between B and C, and he finds out they're parallel. And then he measures the distance between A and B, and they're parallel, and verifies that. And then he needs to see if all of these will be parallel then. All right, so are Caesar's measurements sufficient to show that A and B are parallel to the ground or to the floor, just like C is? All right. Well, we know that the floor is parallel to C. All right. We know that C is parallel to B, and B is parallel to A. Now this is a flow here. This is like the chain rule that we talked about. This is transitive thought, where this is parallel to that, that is parallel to this, and this, these two are parallel, and then this is parallel to that. So because the chain rule, they link together, that means that these also have to be parallel. So are they sufficient? Yes. And here's why. Because you can link up, the transitive rule here that applies in linking these all together. All right, go to 17 now. Identify the property that justifies the following statement. segment AB is congruent to AB. Well, that property, if something is congruent to itself, that's the reflexive property. Now, if you go to lesson 2, we had that little box that talked about things that are reflexive, or things that have symmetry, or things that are transitive. So review that box in lesson 2. But clearly these are congruent to themselves. A and B. AB is congruent to itself, so that's the reflexive rule. 18. What is the intersection of RS and TU? Okay, what's the intersection? That's the crossing line, so the intersection is point V. So you can write point V like I did, and that's officially naming the intersection. 19, identify the intersection of planes M and N. So this is, you can see this this is plane M, this is plane N. This plane is going that way, and this plane is going that way. So the intersection is this line right here, line CD. Remember that planes always intersect at a line. So that's what you got to be looking for when you're asked to look for intersecting planes, and where their intersection is. And then finally, name 3 rays in the diagram below. So we have AB, AC, and AD. Rays always start with the point of origin, which is this point here, the vertex of the angle. These are also, remember, called sides of the angle. That should do it. I hope that's review. You can always go back and review all these problems, rewind the video if you need to.